Ladies and gentlemen, boys and girls, welcome to one more session of AI 430. Today, we are going to cover a very important topic and one of the biggest limitations of large language models. We're going to talk about hallucination. Well, it has been identified by this particular research paper that hallucination is a innate limitation of large language models. So essentially, there cannot be any large language model which does not hallucinate. They also clearly mentioned that they understood via this research that LLMs cannot learn all the computable functions. Now, since it cannot learn all the computable functions, therefore it definitely going to hallucinate. Now, they say that the formal world is a part of the real world, which is more complex. Now, in a complex world, it is definite that hallucination is inevitable. Now, as a practitioner, how you are going to overcome this challenge? Well, today I'm going to talk about three sure shot methods to reduce hallucination. Okay, so without any further delay, let's get started. My name is Shubhradeep. I make videos on GenAI, large language models, and you can find all of them with AI 430. Let's get started. So here we are going to talk about the first methodology. The first methodology to overcome hallucination is called guided prompt engineering. Now, what is guided prompt engineering? I'm going to give an example. Now, consider that you are writing a prompt whose responsibility is to summarize the research paper, impacts of greenhouse gas emission on polar ice melt. Then, if you are giving a prompt which is as small as this, with so limited information, chances are there that it will hallucinate. Now, what I consider this as a bad prompt. So this is a bad prompt. Now, what is the way out? The way out is this. You have to go to a methodology which is called succinct structured prompt. Now, looks a lot of work, but believe me, this works like wonder. So now see over here. At the first part, we have given some metadata of the research paper, the title, author, and the published in and the DOI. So, well, with this information, you really help the LLM to pinpoint to the research paper that you want to extract information from. Then here, what we have given is what is the full abstract, what is the full text, and then what I have given over here is my requirement. So provide a summary of up to 100 words, ensure all statements are supported by the information provided. So remember this specific word supported, up to 100 words. And finally, avoid including any details not explicitly stated in the input. So it clearly mentions here that do not build your own content. If anything is not explicitly mentioned, do not include it. Well, so this is a great prompt which is going to help you reduce down hallucination to the best possible extent. Okay, with this, we are going to the second methodology. So what is the second methodology? Okay, so let's take an example. So here you can see in my screen, I've taken an example. So this example says that, tell me about the causes of French Revolution. Now, believe me, if you give such a small prompt, it is definitely going to build up its own content far away from facts. So what is the way ahead? So the way ahead is positive prompting. Now let's try to understand what is positive prompting and what all things we have done over here. So in positive prompting, as you can see, it is a lot more detailed prompt. So here I am asking it to provide a factual summary of the causes of the French Revolution. And I'm saying using only verified historical facts. And then in the second pair, I'm saying that if specific causes are unclear or not explicitly known, state some details are uncertain based on available historical records. So I'm clearly saying that do not build your own content. And if you're not clear, then explicitly mention about it. The next thing that I'm doing is I'm saying avoid making any assumptions. So this is a historical event and I don't want to deviate myself from facts. So I'm saying avoid making any assumption. So what I've done over here is that I've stated the focus. What kind of answer is expected, whether it is factual, grounded, and very precise. I've set the boundary, defined what the model should and should not do. And I've ensured that to encourage honesty, allow the model to admit gaps and limit in its knowledge. And number four, reinforce reliability. Using the term like based on known facts, verifiable sources, or widely accepted. This kind of phrases tells it to reinforce the fact that we are looking for reliable answers. Okay, this is great. So these are the two methodologies in guided prompt engineering that you can use to ensure that your models do not hallucinate. Okay, we are going to the next methodology, the second in the row. So what is the second methodology that we have? The second methodology that we have is called model hyperparameter tuning. So there are these beautiful 5 parameters that most of the LLMs have, which you can tune to ensure that you are getting predictable answers. So first one in the lot is temperature. So temperature, essentially, you can give a value between 0 to 1, or you can give a lesser value and a higher value. So if you're giving a lesser value, then essentially your results are more predictable. If you're giving the temperature to a higher value, then be assured to get some creative responses, which might be something which the LLM has created by its own. So just be aware. The next thing is top P. Top P, the P which you can see over here, this actually talks about the P, the probability. Now, if you give a higher probability, then chances are there that it will go into a larger pool of words and then start predicting the next token. So the challenge here is that mostly in the pool of 100% or a probability of 1, you will have a lot of long tail words or a lot of words in the long tail with very low probability. Now, if you start picking it up from that pool, there might be a lot of creative answers, and these answers might not match with the fact. So chances are there that your LLM will hallucinate. Over here is top K. Now, what is top K? Top K essentially says that we can limit the number of tokens. So if K is equal to 50, this means that we are limiting ourselves to the top 50 tokens. This is not directly related to probability, but it clearly says that limit the number of tokens which is needed to predict the next word, or to predict what the output of the LLM would be. Okay, the next thing that we have in line is called frequency penalty. So frequency penalty and the next one, which is presence penalty, the two almost work in a very similar way. So frequency penalty says that if a word is or a token is repeated multiple times and you have given the frequency penalty value to a higher number, then definitely it is going to ignore those and penalize those. That means penalize those. Whereas the next thing is presence penalty. So in the presence penalty, if a particular word is present, then it is going to penalize that. So you have these 5 parameters or hyperparameters which you can tune in your LLM. I've made a detailed video called tuning top 7 hyperparameters, and you can learn all of these 7 parameters in just 7 minutes. Well, I will put a link to this video in the description, and you can click and watch this one. This 7-minute video gives a total detailed understanding about how you can tune a LLM using these hyperparameters to match to your results. Now, to summarize this, all these 5 parameters, if you're taking a lesser value, you're limiting the creativity and thereby you're making it more or less well-determined deterministic results. But if you're giving it more values, then the challenge is that it might be more and more creative. And if it is more and more creative, chances are there that it will assume something, it will build up its own content, and the LLM is going to give output which are assumed, built up away from fact. That means it will hallucinate. Okay, hallucination is great when it comes to creative writing, but then there are fields like finance, healthcare, or the legal field where you definitely don't want your LLMs to hallucinate. Okay, so with this, we are going to go to the next methodology. So the next methodology that we have is called Retrieval Augmented Generation. So this is the third strategy that you can use. So let's say you already have got a pre-trained LLM. Now, pre-trained LLM would have been trained on a massive data set, and you want your LLM to give precise information to your user based on some facts and some details that you feel should be at the top priority. Now, what you can do over here is that you can bring in your own knowledge base. Now, in retrieval augmented generation, there is a retrieval model in place, which you can see over here. And then what it does over here is that it fetches the information from your knowledge base, which is here, and based on the query that the user has asked, it actually attaches the retrieved information, pushes it to the LLM, and gives the relevant information out to the user. This ensures that whatever information which is custom, specific to your knowledge base, which the pre-trained LLM does not know, it should not hallucinate, but instead pick up from your knowledge base, append it in the right language structure, and give an output to your user. Okay, so this is the third important strategy. Just to summarize, we have seen three strategies. Strategy number one, we have seen guided prompt engineering and its two variants, succinct prompting and positive prompting. Number two, we have seen how you can take 5 parameters or hyperparameters within an LLM, fine tune it to ensure that it does not hallucinate. And number three, retrieval augmented generation. A little more elaborate methodology, but it can ensure that your user gets the right response and your LLM does not hallucinate. Okay, I think that's all I have for you today. Thank you so much for listening to AI 430's YouTube channel.